Thank you very much, Thomas and Katrin, for the invitation and for the introduction. Very kind of you, and it's a pleasure to be here, of course. I'm a climate modeler, physicist by training. So what we do in our daily lives is modeling the climate system and making predictions about the future, but I want to keep this much broader. And I will spend a bit of time on the basics of climate science, but then also a bit on the societal debate and political debate and I must stress that from a perspective of someone who experiences that in a daily life, not that I do any social science research. Just to get you a bit into a mood of what we're talking about, I'm sure you've seen some of these pictures before. This was 2018, the driest summer in Switzerland ever recorded so far in the Jura here. Pictures like these, you can see them in Australia, in California, and Southern Europe, everywhere. Climate change, of course, not the only reason for that, but one of the more and more important drivers of wildfires. Pictures like these ones here, Ida in this case a few weeks ago in Louisiana and later in New York City. And you wonder what's happening here. Is this all normal or are we seeing something unusual? But of course, it's not just these. It's pictures like this one here, a whole generation of young people, and not just the young, walking on the roads and basically saying, hey, can we have a discussion about what's happening with our future? The Glacier initiative started a few years ago. Many said this is absolutely meaningless. You're never going to get any signatures for that. And within a relatively short period of time, they got those, and we are going to vote on this next year. The Parliament will discuss the Gegenvorschlag in the next few weeks. The Glacier initiative mentions the net zero goal to be written into the constitution. And the government, in fact, in 2019, already the Swiss federal government said that Switzerland has to become net zero greenhouse gases by 2050. Some of you may not have realized, or maybe you have, we've never voted on that one before, but it's, of course, scientifically been clear for a very long time that this is the only way to get to a stable climate. Now, zero. If you just think about it a little bit, then zero CO2 and greenhouse gases, this is not just changing things a bit and saving here and there a few percent and becoming a bit more efficient. Zero means a fundamental transformation of how we produce energy and of much of our society. And you realize that this is going to be a challenge, as I'm sure I've heard during the day in your lectures and discussions before. So where does this come from? Of course, you have to start with the basics of what do we actually observe. And the climate reports of IPCC, the Intergovernmental Panel on Climate Change, have already stated in 2007 that warming of the climate system is unequivocal. So there's absolutely no question that something is happening. That's the same as the doctor taking a fever thermometer and just measuring the temperature. It doesn't tell you what's happening and why, but it tells you that something is probably not quite right. How do we know? Of course, you can measure many things, but the most prominent ones are probably global mean temperature here, starting from 1850 to today. And you can see that in particular, the last 50, 60 years were really, really unusual. We've seen a warming of about 1.2 degrees over the last century globally. If you do that for Switzerland, from 1860 on the left to today on the very right, you can see that the last 20, 30 years on the right part of the figure are really unusual. In Switzerland, we've seen about 2 degrees warming over the last century. And for those who don't like the numbers too much, you can also just go into the mountains and see what's happening. This is the Rhone Glacier in 1850 approximately, and the end of the 20th century. If you stand here today, there is no glacier nearby or inside. There's a lake up there. So the changes are dramatic and they're fast. The second question, of course, is why is that happening? So the doctor would then start with some hypothesis of why there's a fever, why are you sick, and you would need detailed tools to figure out the specific reasons. In this case, the climate reports in 2013 already have stated that human influence on the climate system is clear. That doesn't mean, of course, that everything we observe is climate change. Of course, weather is variable on a daily timescale. There may be storms occasionally without climate change, no question. But on the largest scale, in the long term, we are absolutely sure that humans are the dominant contribution to the long-term warming, and therefore at least partially responsible for many of the impacts we're seeing as well. How do we know? We can, of course, look into the past. This is one interesting way of reconstructing climate. You go to Antarctica, there's a 3 kilometer thick ice sheet here. And if you dig a hole here, you dig back in the past, so that the deeper you dig, the older the snow and the ice. And of course, the further you go, the faster, the later, the earlier in time you are. You can drill a hole that's more efficient than digging 3 kilometers down, and then you can reconstruct almost 1 million years of history of climate, and you can measure various things on those ice cores. The most prominent ones being the concentrations of greenhouse gases, in this case CO2 and methane, the two most important greenhouse gases released by anthropogenic sources, in particular the burning of fossil fuels, of course. And that starts 800,000 years ago, and you can see that it has changed over the past and has varied, and then at the end something happens that doesn't need a lot of statistics to figure out that it's unusual. We've increased CO2 in the atmosphere by 50% over the last just a century or so, a bit more than a century since we started industrialization. So the changes today are really, really unusual, and they're extremely fast in a historical context. And you would need to go back at least 2 or 3 million years to find a similar state in the climate system. The human species in their current form is less than 100 or 200,000 years old. So this is not something that happens every once in a while in that sense. And of course, we know the reasons for it. And this animation, I hope it's visible for you. It usually works not too well over Zoom, but it does at least a bit. This is the laws of physics in the computer. So if we take the basic laws of physics, thermodynamics, conservation of mass, angular momentum, energy, and so on, and we put it in the computer, this is what you get. So that's not a satellite movie, but that's a simulation. It's what physics tells you what needs to happen in the atmosphere. So we've understood the basics of atmospheric dynamics and thermodynamics since more than 100 years. The first physicists to look at the greenhouse effect were around 1800, 1850, and already by 1900, the first physicist said it should be warmer with more CO2. So we know why. The third question, of course, is then what do we do with it? And interestingly, this is the hardest one, right? And to take up the medical context again here, you could say, I'm just going to ignore it for the moment or pretend it's not there. Or I could say I do a flastily politik. I wait and see, and if it goes wrong, I will fix it. It may not be very smart, but it's possible, and we do it all the time. Or you could say, no, I don't want this to happen. And it's really important, and I stress that all the time in every talk. It's really important that we all agree that there is no law of physics that tells you what needs to be done in response to the things you observe. Right? There may be things that are smarter than others, but in principle, it's your choice. The facts, the scientific facts and the numbers, they do not, in principle, dictate political action or any societal choice of what to do. Sometimes we are attacked as climate scientists saying you're just stating what the policies need to be and you're trying to impose something on society. No, we don't. In a sense, what we do is we produce scenarios. We produce storylines of the future saying, okay, if we do this, that's going to be the consequence. And if you do that, that's going to be the consequence. not making any value judgments about what needs to be done, because that's something that society as a whole needs to do. Of course, there are situations where some scenarios just make more sense than others, and then I think we should also say so. So here's a story about the future that would maybe be the vegan high-tech story of the future. Here's another one. And there is no law of physics that tells you which of those stories of the future is the right one or the better one, unless we have a discussion of what we mean by better. And that's important. We need to find out what we actually want. Where do we want to go as a society? And of course, there are similarities all over the place. If you just reflect for a second with the pandemic, you can estimate the R value, and you can estimate cases, and you can estimate probabilities, but that doesn't necessarily dictate what you want to do with those case numbers. Right? What's your goal? Do you want to minimize the number of people dying? Do you want to minimize the number of people in hospital? Do you want to whatever? Right? There are different goals that you could potentially agree on. So what climate science does is producing scenarios, and here's a range of scenarios. The left one would be one that's approximately Paris compatible with 2-degree warming, not quite 1.5, but still reasonably okay. The right one would be a high emission scenario stabilizing at 4 or 5-degree warming. And then you can downscale that to what would happen in Switzerland. Here's the number of hot days, for instance. On the left is you would have 15 to 20 days with temperatures over 30 degrees peak temperature. On the right, you would have something like 30 to 40 days per year with exceeding 30 degrees temperature. So heat is a problem for elderly people in particular. Drought is a problem. In particular, the summer will dry for less rainfall and higher evaporation. Here's an example of a farmer near Zurich. He had a bit of carrots, and he said they're not growing, so we'll just start again next year. I'm sorry for 2021. That's not the kind of summer you would necessarily expect in the future, but it can happen. At the same time, when you have drying in summer, you have a tendency to higher peak precipitation. So it doesn't rain for a long time, and once it rains a whole lot and more than it should. And we've seen that many times this summer. In the better case, it looks like this. This is in Thun, the lake of Thun, the sidewalk being flooded. If in the not so good case, you get what you got in Germany with 200 people dying and billions of damage. So, and again, that's actually a very basic thermodynamics. 2 degrees warmer means that the air can hold about 15% more water. Again, that's more than 100 years old, a fundamental principle that the physicists have discovered back then. So if you have more water available in a thunderstorm, inevitably it's going to come down somewhere. And the last one, of course, for Switzerland is the tendency towards less snow and melting of glaciers. We have already seen an increase in the snow line of about 400 meters, and it will continue to increase in the future. The glaciers, here's the Alleged Glacier, also in a simulation for a high emission scenario. And you can see that by the end of the century, even the longest and the biggest glaciers in Switzerland, there won't be much left. For those who have been up there, Concordia Platz is about 700 meters of ice still today. So the changes are really massive. And of course, that affects availability of water for agriculture. It affects water availability for power, for cooling capacities, and so on. We know a lot about climate and about the impacts, but we have to also realize that it's not easy. And I'm showing a last animation here. I hope it's streaming okay. This is a weather forecast on a 1 kilometer resolution, so really very detailed. And the blue is rainfall, and you can see that how small scale and fast those changes are, these rain bands. You could also look at the radar on your phone almost any day since April or so, from April to August at least. This is really hard to predict, and we can predict the weather for tomorrow for Switzerland, but we cannot do this for a whole century, for the whole globe. So it's challenging from a science point of view. It's also, of course, impossible to exactly predict what humans are going to do, because human decisions are sometimes not very rational. So where do we go? The current commitments, or the current, and it's not the commitments, but the current policy. So the implemented policy for all greenhouse gases look approximately like this. So we would have nearly stable greenhouse gas emissions over the next decades. If we focus on CO2 for a moment and leave out the non-CO2, this is what CO2 emissions would need to do for a Paris compatible target. And you can see that those do not go to zero because there are some emissions that are hard to avoid. So they need to be compensated by so-called negative emission technologies, so removing CO2 actively from the air through either some afforestation or treating soils differently, but also technical removal, direct air capture, carbon sequestration, etc. Maybe we can talk about those in the discussion part. And the net of those would look something like this. So you'd have emissions essentially going to approximately zero in 2050. That's where the net 2050 zero approximately comes from. Of course, there's a bit of a discussion of when exactly that should be. That depends on the shape of the curve. You could also question whether Switzerland should be earlier than other countries because of whatever reasons. We can also discuss that later. But once you have a decision for a temperature target, and we have had that in Paris with 2015 for the target of stabilizing temperature at much less than 1.5 degrees, then of course science can tell you what needs to be done, and that's the consequences here, the net zero. Where are the emissions in Switzerland? They are in road transportation, about a quarter. They are in air transport, about 20%, maybe even a bit more, with most recent estimates of the indirect effect through contrails and so on. It's in houses, so oil and gas heating. It's in industry, in agriculture, in services, and in waste. So it's essentially everywhere. Some things are easier than others. Electric cars are obvious. Changes in heating are obvious. The hard ones are the air travel, with synthetic fuel still being in very early stages. Agriculture is hard. Some of the petrochemical processes are hard. Cement is hard. So there are sectors where emission reductions are difficult or expensive, and that's where the negative emissions might come into play. So that was this kind of the science part. And you might say, well, okay, it seems like everything is clear. Or in Sherwood Rowland's words, one of the people who discovered the effect of chlorofluorocarbons on ozone depletion, he said, what's the use of having developed the science well enough to make predictions if, in the end, all we're willing to do is to stand around and wait for them to come true? And I think he has a point, obviously. We should do something about it. So why is it really so hard? I wish I had a complete answer. I don't, but I'll give you a few perspectives of why we are where we are. I think the first one is the issue of fake news, ignorance, lies, and a perceived debate. It's becoming more and more difficult to educate people and tell people what's true. In the better case, this is what it looks like. That was a few years ago. You can read the interview, of course. You can partly have an influence on the photo, but you're never going to see the title. So obviously the newspapers, they don't want just informed, objective, and nice and deep discussions, but they want debates and they want to tell stories. In the worst case, it goes like this. This is from a Russian or Ukrainian website. They're titled "Humanity has 3 calm years," and then basically that's the end of the world. Today, people just sit down and they write an interview with you without ever of course, having spoken to you with quotes. That never happened, but of course it's impossible to stop. Fake news are spreading about 5 times faster than real news, and it's really difficult to control what's out there. Even for experts, it's sometimes really hard to understand what's going on and what is true and what is reliable. So how do we make sure that we produce reasonable information and get it to the people? The second issue, of course, is economic interest and power and lobbying. This is from 1988 from Shell, a report entitled "The Greenhouse Effect," labeled confidential. The fossil fuel industry knew in the 60s, maybe even earlier in the US, what the problem was. And the same way as the tobacco industry knew, but they spent a lot of money trying to sponsor research to find out something that contradicts the current view. They spent a lot of money for advertising, and they spent a lot of money lobbying politicians and to prevent any sort of regulation. And if you think that's just in the US and it's just in the past, obviously it's still true today. We also have, of course, an issue of fairness. In a sense, we've eaten most of the pie, and there's only a bit left. And the question is who gets the rest of the pie? Is it the developed countries who are relying on the pie? Or is it the developing countries who haven't had much so far? Is it the current generation who is so reliant on it, or is it the next generation? Of course, every bit of pie that we eat is not going to be available for the next generation. So this issue of burden sharing has been one of the difficulties in the political negotiations for a very long time. And it's not easy, right? What is a fair share? That's a hard one. And then, of course, as I stated before, how do you make sure that the numbers and the facts are heard and something is done that makes any sense in the public discussion? If you can, I'm not sure you can read it on the back. On the left is the COVID experts. On the right is the climate scientists. And he basically says, as long as we just provide the facts to the American people, we have, I think, as scientists, been in a somewhat naive position or view that we thought if the facts are clear, then people are going to listen and we'll have a rational debate of what we're going to do about it. In reality, that's often not the case. And the reason is, of course, that facts are only one thing, but people have different viewpoints. They have different perspective on something. And that's real, and it's not just, of course, something that is on one or the other end of the political spectrum. It's normal. The facts and the numbers are meaningless unless you provide some context, and that context is inherently dependent on where you come from. For those who know Mani Matter, he wrote a song called Isebahn. There's two men opposing each other sitting in the train, and they're looking at the landscape, and one of them is always seeing what's coming and the other one is always seeing what's already passed. And they're fighting because they disagree. Even though they're sitting in the same train and they're looking at the same landscape, they disagree on what they're seeing. Sie gaan along over ring, for those who know it, and in the end the conductor, he comes and says, so we see the world from a certain viewpoint, and that viewpoint matters more than we think. Sometimes we think we disagree on the facts, but mostly it's because we disagree on what those facts mean, what they imply. And that's maybe best described or shown in this graph here. From the US, over 20 years, they asked the American people, has climate change already started? Do we see the effects? And that starts with about 50-50 in 1996 or so. And then it goes further apart as we go along over time. And those who believe, they believe even more, and those who believe who don't believe, they're even more convinced that it's not true. Even though, of course, the facts are exactly the same for everybody, we're getting to the point where viewpoints on climate, but also for other things. I mean, viewpoints on vaccination are starting to be a political belief, almost like a religion. And there's really like nothing in between. There's no intermediate thing. You either believe or you don't, almost in a religious sense. And of course, it has nothing to do with facts in this case here. It's just because the facts, in some case, they fit into people's worldviews, and in the other case, they don't. So if you think the best of all possible worlds is a world without any laws, without any taxes, and complete freedom and no government, if that's your view of how the world should be, then you have a problem with climate change. Not because of climate, but because of the implications of political regulation that might follow from the facts on climate change. So it's not a disagreement on climate, but it's just a disagreement on what to do about it. So the next time you fight with someone on one of these issues, it doesn't need to be climate. Just take a moment and think about whether you're fighting about the scientific evidence and the numbers, or whether you're fighting about a political viewpoint. And it's likely that you're fighting about the perspective you have, right? It's a clash of worldviews, not about facts. You could push it a bit further. This is from the inauguration just after Trump came into office. I was in the US, so that kind of shattered my worldview a bit. The Washington Post showed those two pictures to people, and they asked, where are more people? And about 15% of the Republican voters said, on the left with Trump, there are more. Obviously, every child would tell you the right answer here, but the reality is that if you're really convinced about your political position, then people are willing to lie. They're willing to obviously lie just because it fits their political viewpoint. And then, of course, no additional facts are going to help. You can provide as many facts as you like, it's not going to change their worldview. So these are some of the reasons I think why the debate is the way it is. And that sounds all a bit negative. I want to close with one or two slides that are a bit more positive on why I think things are changing a bit. And really, I see a change in how people are educated and how they think about climate because of the young generation. Obviously, in the last 2 years or so, since the Fridays for Future, the awareness for climate change has massively changed. That's a good thing. The other is that I think some of the businesses, at least the bigger ones, are realizing that this is becoming an economic reality. The economists have shown us very convincingly that there is no contradiction between a healthy planet and a healthy bank account. It's easier and it's cheaper to fix the problem than to wait for things to go wrong and then pay later and fix it afterwards. Or in other words, the most expensive thing to do is to do nothing, right? Because things will go wrong and we will pay in one way or the other. So many of the big companies, in particular, if you think about IKEA and Swiss Re and Nestle and Novartis and you name them, they have changed, and I get a lot more requests from big companies saying, listen, this is an economic reality. It's also a business opportunity. We want to know what to do about it because we'd rather change things now than for waiting for regulation or waiting for problems with the government intervening or public pressure and shitstorms and so on. So I think things are moving in the business world. Things are moving, and you can see it here. Also, in the World Economic Forum Global Risks Report in 2020, they identified the biggest risks facing society. On the horizontal is likelihood, on the vertical is impact. So on the top right are the sort of top risks, and in this case, 6 of the top 7 risks are related to climate and environment. It's extreme weather, it's disasters, it's biodiversity, climate change, food, water, and so on. In 2021, the pandemic has come into this chart, but I think still 4 of the 5 top risks are related to the environment. So obviously, and that's not something that scientists produce, but it's people from business and government who are completely aware, I think, that in the long term, these are going to be the top risks. So the science is important. The numbers are important, but the numbers are not going to be enough. And I want to end with the quote by Kahneman, the economist, and who once said, "No one ever made a decision because of a number. They need a story." And the story is, of course, not a story of a single person, but the story is a vision that we develop as a country, as a society, of where we want to go. If we manage to tell a story where people can identify, when they can see a certain purpose, and where they can see that they can make a contribution that even helps them, and is in a positive sense, people, I think, are willing to do a lot, and they're capable to do a lot. So, summary. Climate change is real. It's mostly anthropogenic. Humans are responsible. The impacts are very diverse, but on long time scales, they're mostly negative. We really don't have much time to decide. What we do will affect the world for many centuries, if not millennia. Much of the climate change is basically irreversible once it's there. For the Paris climate targets, that CO2 emissions need to be net zero around 2050 approximately, and the current efforts are not sufficient to get there, both in Switzerland and worldwide. It's technologically and economically possible to achieve an ambitious climate target, and there are strong economic incentives also to reduce the risks. It's cheaper to do that than to fix it later. I think we've never known so much about science, and it's never been so easy to do something, but of course it needs the political will, the vision, and the leadership. It also probably needs some political boundary conditions for this to happen. Thank you very much.
Reto, thanks a lot. Super presentation, very factual, very clear, very sober. Let me start out with the first question concerning you as a scientist. Recently, there has been a new debate starting on methane as opposed to CO2. Can you fill us in about this new discussion? What is this about, and what are some of the consequences of this?
Yes, thank you. It's not really new. Methane is known to be a very powerful greenhouse gas. In fact, the methane as a single molecule is much more powerful than the CO2, but it comes in smaller amounts. So in total, the effect of CO2 is the largest, methane is second, N2O is the third. So methane is the second most important. What is a bit easier with methane is that it has a half-life of about 11 years. So it decays in the atmosphere. So once you do something about the cows, then basically a decade later, half of the problem is gone, and 2 decades later, 3/4 are gone. So it's going to come reasonably quickly, the benefit. While CO2 does not decay, and it basically accumulates, and it goes on and on for hundreds and thousands of years. That's why we're more worried about the CO2, because of that long-term effect. But in the end, we're going to need to do all of that, right? So we will also have to reduce methane, and then N2O and all the HFCs and CFCs and all the gases.
Okay, thanks a lot. Concerning your assessment that you put more hope on the business sector, the companies currently, than on the political side. This is something that I feel with myself as well, and we feel it also, that politics has become so divergent. So if you allow helpless in solving and addressing the big issues, that we come to believe that business at least is more rational, is more sober, and accepts the facts easier than the political side does. Still, I'm afraid without political decisions and clear political frameworks and regulations, we probably will not get very far through business action alone. It will help us get started, but I don't see yet if that really is going to help us out of the situation that we're in.
Can I respond to that? Absolutely, I fully agree. I think the political discussion has been difficult, and especially after the vote on the CO2 law, I think we are a bit lost. I see the change in the some of the businesses, in particular, big ones. They see it as an economic reality. They basically say we'd rather do something now than be in huge trouble later. But I fully also agree with what you said additionally, and I should have mentioned that, of course, if you look back in the history of environmental problems, there is not a single one that we have solved by a sort of random innovation and markets alone without any rules. And you can start from solid waste, you can start from clean water, clean air, the ozone hole, asbestos, pesticides. Every one of them has been solved by clear rules or boundary conditions in one way or the other to force also those who do not necessarily want to change in the right direction. So I do think we need some boundary conditions from government to make this happen. So
business action may help government to get into the act again and do their job finally. It's yes. Probably going to be various elements that contribute, but it's encouraging that some of the businesses now, I think they're seeing an opportunity to do things differently.
Joy, I see your hands are raised, so if you unmute yourself.
Yes, hello everyone. Hi Reto, thank you so much for this very interesting and thought-provoking presentation. I just have a question. I'm looking at your LinkedIn profile, and you've also mentioned that you were in the Climeworks Summit. So I just want to take your view on direct air capture technology, how promising you think it is, how feasible it is to roll out at a larger scale to try to solve a little bit of the climate crisis.
Thank you. That's a good question. My short talk on the Direct Air Capture Summit at Climeworks is online for those who are interested. We will have to do 80 to 90% with mitigation, so avoiding CO2 emissions wherever we can, because then that's going to be the easiest and most straightforward thing. That's particularly true for road transport, for heating, for most of it. But there will be, as I said, some elements that are hard to decarbonize, and partly it's not the CO2, it's partly other things as well. So that's going to be cement, air travel, agriculture. And for those cases where we cannot completely get rid, we need something else. And that can be either planting a few more trees, although the potential of that is relatively limited. It can be to charcoal. So there are various biological things, but we probably also need the technical options. So that's taking CO2 out of the atmosphere and burying it underground. That works today, and it's safe, but it costs about $600 a ton today with Climeworks. So that's a lot of money, and it's only worth doing that if you have really no other option. But we will kind of as an insurance for those things we cannot avoid, we'll have to do that, and we'll have to, and that's important, we'll have to scale up the technology today, because it's going to take us 10, probably more like 20 years to get it to a stage where it's reasonably cost effective and also available in large amounts. So it's the same as to photovoltaics. It took 20 years for these things to be cheap and easy to install. And so we'll have to accelerate this learning curve.
Thanks a lot. We have a question in the room. Piane?
Yeah, sure. Yeah. We have worked on hi Reto. We have worked on the pledge of the companies, the big companies, and we see that it's not really yeah, it's not really readable, or it's not easy to compare. And so my question is, are there some scientists that do not work on what we need to do, but what is being done by the economy?
I am not aware of scientists doing that. This isn't really a science thing, at least in a traditional way of gathering citations and scientific papers. This seems to be more like a consulting thing, but there are I think companies who do to try to track commitments and all of these things, or also financial products. So I'm sure that the consulting business sector has some of that.
Okay, we've got more questions from our alumni. Sandro Müller.
Hello, everybody. Hey, thanks a lot for the presentation. You briefly talked about it, the politics and science, and I know it's a reoccurring topic. What do you think is should scientists go more into a political role, or should they stay factual based like they have been? Your personal opinion, and maybe what is sort of the consensus in the science world? That would be super interesting to hear.
I think the view of the science has changed a bit in that, and I'm probably further into that process than many others. As I said in the last quote by Kahneman, you can provide the numbers, but the numbers do not speak for themselves. You need an interpretation of those numbers, and you've seen it with the pandemic, right? The case numbers do not mean much if people do not understand the exponential increase and they do not understand what that means. That's a problem. So someone has to go out and interpret those numbers and what could be done about those numbers. The science, the politicians and society need to know. If we as scientists don't do that, someone else is going to do that, right? With very different interests. So in COVID, there's going to be the Gastronomieverband and the Seilbahnen and everything. They are going to tell you what should be done, right? And of course, they have no clue about what's at stake, but they have their corporate interests. So I do think science needs to stand up and say what's happening. And we cannot decide as scientists what should be done, but at least we can provide the options. Having said that, it's of course not a core responsibility of a scientist to go into politics. We're not paid to do that. We do teaching and research, and this is and the whole media and outreach is essentially a hobby, and many don't spend too much time on that. So, but I do think we need to have incentives for scientists to at least for some of them to do that as well.
Thanks a lot.
I just want to add some questions from the chat. I know, Reto, that you paid attention to the chat. Judith Werle, who is a journalist on SRF Radio, SRF DRS3, is also very much into stories and was asking about, hey, but where are we finding all these good stories to share?
Yeah, that's a good question. What are those stories? I think it's partly a question of finding the stories, but also who is telling the story. You can demonstrate that this is not about intelligence, but it's about emotional connections, right? We are like sheep in a herd, and we follow the other sheep that we think are knowing where to go, right? So there's probably a story. Give you an example. Mammut, the company who produces alpine products, is now going heavily into the sustainability, and they're producing books about. One is coming up in December with pictures from mountains and with stories about sustainability. This is going to appeal to someone who maybe grew up in the mountains or likes the mountains, and because it's coming from alpinists, it's going to be a different story than if it comes from the scientist. Another story would be the one that religion and the church might be telling about, and they don't, right? I mean, there's a whole lot of issues of fairness and ethics and looking after the poorer. why is the church and the Pope not engaging more in those stories? Then there are stories about the high tech, right? There's lots of people interested in solar panels on the roof and Teslas in the yard, not because they want to save the world, because they want to have something to play with, gadgets, tech, right? So there's probably tech stories and people who could be excited by that aspect of the story. So I think it's a question about what the story is, but also who could be the messenger to tell the story.
Thanks a lot. We got a question from Yvonne Isaac Kessely. Yvonne.
Hi. Yes, it's a privilege to hear Professor Knuti, so thank you so much for this. Really amazing. The presentation was really great. Just a quick one maybe regarding compensation. And obviously, maybe I'm too simplistic here, but I feel sometimes, be it with consumers, but also with corporates, that there's this real enthusiasm, like, oh, we can always just compensate. And obviously, when you look at things like additionality in compensation projects, or when you talk to biologists or botanists to really show the actual border of what planting trees can do, what is your view? Do we need to do even more interdisciplinary work between physicians and or people from physics and biology, and really just educate the public more about the limits of compensation? And then again, I mean, being the skunk at the picnic, as Dr. Fauci would call it, you know, everyone's sort of excited about compensation, and here the botanists come again and sort of destroy the party. So what's your view on that? Thank you very much.
Thank you, Yvonne, for a great question. And I largely agree. I mean, the basic idea is simple. You should reduce emissions where it's easy, right? Because it's cheaper. So if you can do more with the same amount of money somewhere else, then why not do it there? Because the climate really doesn't care where the CO2 comes from. And that's where this compensation comes from. Basically, 1 Swiss franc is better invested in India than in Switzerland to reduce CO2. And that's why some people and parties and think tanks, if you ask Avenir Suisse, for example, they would say, we just pay a price on CO2 and then we do it wherever it's economically the most convenient. Now, the problem is with this emission trading and certificates is, as you say, most of these emission certificates abroad, they do not really fulfill what they promise. So you get less than what they promise. The additionality is a problem. So if you replace an old stove in India and that would have been replaced anyway because of other economic reasons, then obviously you haven't gained much, right? The second or the third point is that these these compensations abroad, they will soon become very expensive or no longer exist, because if we have to go to net zero everywhere globally, then there will be no compensation anywhere. So it's a short-sighted thing that may look attractive, but it doesn't eliminate the need for you to rebuild your own infrastructure. So if you have an old heating system, you're going to have to replace it anyway, sooner or later. And then we often underestimate, of course, the benefits of doing something here in terms of innovation and jobs and so on. So there may be lots of benefits of doing it here. And then the last one is, of course, if we just pay abroad and don't do anything here, that's the classic form of the Ablasshandel, which is not going to be very successful. If we cannot demonstrate that we can do it, then it's going to be very difficult to convince others to do that who have less opportunities and money and technology. So I always go with the principle that one of those compensation companies put forward. I don't remember who it was. Do your best and offset the rest. It's pretty simple. So if you can do it, then do it. If there's really no other way, if you absolutely have to fly, then it's better to fly with compensation than without. But as I said, 90% will have to be real actual emission reductions, and only a small percent will have to be by compensation and later negative emission technology.
Thanks, Reto. We have a question from Stefan Gara. Stefan is member of our faculty and he is politically active in Vienna. Stefan.
I can't hear you, Stefan.
Muted. Yeah.
Yes, first of all, thank you very much for your excellent talk. And I really agree. I'm somewhat in these two positions. On the one hand, I'm also trained in physics. And on the other hand, I'm now part of the city government in Vienna. And what I like to address here is, I think what's really important is to also focus on the role of cities and regions. Because in many cases, mayors of cities are much closer to the people and are much more willing to change than on the national level. So I think that we have a strong movement from cities and regions worldwide, because then they become very interesting also for companies to show their options on technologies. Because in cities and regions, it's like there you really have to walk the talk. Not only do the legislation part. So I think, I mean, this is what we experience in Vienna, and I will present to the class some of my insights and things we do in Vienna. We now the city government has like climate neutrality towards 2040, and we have no natural gas, complete mitigation from natural gas until 2040, which means for a city like Vienna with like 600,000 gas installations in the homes. That's a huge movement. And what's the story? Because I think that's a very important part. Well, the story is especially companies in the building sector, they now understand that their assets in the future might be lower than they're today. So they're really interested to change. So that's a combination. How do you build the right boundaries, the right legislations, actually also in partnership with companies. Yeah, so that's just another view in this direction, that I believe cities and regions are one of the game changers. I mean, it's like the book, if mayors would rule the world, would that look differently? And then they are great examples of what can be done. And you can see it in New York City, you can see it in a lot of big cities, or especially where the impact of climate change is really a big stress for the cities.
Thank you very much. That's a very good point. Yes, I think there's a lot of potential there. It's of course not covering all the sectors. If you think about taxes on fossil fuels, that is probably not going to be on a city level. In Switzerland, most of the building subsidies are done by the cantons, so there are things on various levels depending on the country. But I agree, there's lots of potential there as well.
One last question, maybe Bertrand Jacot.
Yes, thank you very much, Thomas. Thank you, Catherine, for having me. Thank you very much, Reto, for this very clear expose. I'm talking to you, to the pure scientist, which I am not. I have, I would say, very little competence. I have the impression the house is burning big time, and a few guys are running around with a few buckets of water trying to extinguish the fire. And most people are still staying in front of the house discussing how we are going to extinguish it. I saw the other day a film called Kiss the Ground. I don't know if you know that film. It's a reportage, and it's, as I understand, it addresses, it considers one big solution. If the priority is to cool down the earth, or to at least stop the global warming, the solution maybe is in the soil, in the ground. If we would restore the soil, which is today very much used, at least in the US and other places, for intensive agriculture, monoculture, etc. If we would just let the soil become natural again, we would eventually be able in 30 years to absorb a good part of everything that was emitted in the last 300 years. And this would eventually be priority to stopping emitting. I mean, the emissions we're talking about now to reduce is maybe the oil that we are still putting in the fire, but we should much more discuss about sustainability goal 15 in restoring, biodiversity, the use of land and all that. And maybe we would, if we had to choose one thing to do, we would be much more efficient. So my question to you as a scientist, do you endorse that? Do you agree? And very honestly, if tomorrow morning the whole world would move to zero emission, would that make a difference for the next 3-5 generations? Thank you.
Thank you very much for a very nice question. I agree that soil agriculture biodiversity is a huge thing, and we do need to make progress on that one as well. But this is not going to stop climate change, and it's not going to reverse climate change, simply because the CO2 comes from burning fossil fuels. As long as you burn fossil fuels, no amount of treating soils differently or reforestation is going to stop that. It's just not going to be enough. Even if you were to completely use all the land that you had, but of course we don't have the land because most of the land is used, and we need to feed 8 billion people, probably soon 10 billion people. So we can't really do that. On the other question, if we stopped emissions today, assuming we could, that would approximately keep temperatures stable at the current level. So it would not go back to pre-industrial, but it would basically stop at the 1.2 or so degrees that we have. So it would make a difference, but it wouldn't go away. If we stop today, we're going to stay at slightly above 1 degree. If we stop in 2050, we're going to stop at 1.5, 1.7. If we stop in 2100, we're going to stop at 3 or so. That's the basic story. So we cannot reverse climate change, but we can decide that being where we are today or going on to double or 3 times as much.
Thank you very much.
Okay, thanks a lot. We are at the end of this first part of the session with your presentation, Reto. Thank you so much. It's been really fantastic. Good to have you here.